Hey guys, welcome to question FM316 of the Further Maths Fortify study guide. This question reads, the peak of a mountain A can be seen from the bottom of a valley B as shown in the diagram below, and then we're given a diagram that looks much like this one. The distance between A and B in meters is closest to what? Now there's a few different ways that you could answer this question. The way that I'm going to show you is by creating a new right angle triangle because of course we're being asked to find the distance between A and B, so we're being asked to find the length of this line here. So if we make that length the hypotenuse of our new triangle, we can find out this base length of this new right angle triangle by adding 5,600 and 1,600 meters. So if you have your calculator, putting those two together should make 7,200 meters. Of course, we then run into a problem when we try to add the heights of the triangle, so the 2,800 and the unknown height over here. So our first job is going to be to find the height of this triangle so that we can total it and then from there find our unknown value of C. So, in order to find this height here, what we know is that the ratio, because these two triangles are similar, and we know that because they are a reflection of one another, they use this same line here, they both occur at right angles, so we know that these two are similar. We know that the ratio of height to base length of one of these triangles should be the same as the ratio of height to base length of the other triangle. So if we take our height and base length of our first triangle, we say 2,800 over 5,600 should be equal to what? Sorry, should be equal to our unknown height over 1,600. From here, you can either rearrange this by hand or use the solve function in your calculator. You should get a value for x of 800 meters. So we've got an 800 meters here, which if we were to add our two heights now, 2,800 and our 800 meters there, we should get an overall height of 3,600 meters. Now notice I'm keeping everything in the meters unit because we've been asked to find the distance in meters, so we want all of our measurements to also be meters. From here, we've got two sides in a right angle triangle and we're trying to find the third side length, so we're going to use our slightly revised formula for finding the hypotenuse of a right angle triangle using Pythagoras' theorem. So we're going to have C equals the square root of A squared plus B squared. Now I've already transformed the C squared equals A squared plus B squared. This formula here will take us straight to a side length rather than having to do the square root as a separate part of the function. So, from here we're going to substitute values A and B with these side lengths. So we've got C is equal to the square root of 3,600 squared plus 7,200 squared. Popping this into a calculator should drop out an answer of 8,049.84, decimals going on for a while, and then meters. So this option here, very close to option C of 8,050 meters, in fact, the closest. Guys, if you have any questions about this question, please drop them in the comments below. Otherwise, I will see you in the next video.